So hello, good afternoon, good morning, and good evening, and good night for everyone, because it's nice to be connected with all different people in different time zones all over the world. That's the nice thing what the current strange situation is bringing us. So at least we can be connected in this way. So I hope that the connection is well. Uh, uh, I would like to start by saying a big thanks to the organizer of this webinar session, to the company PointCap, and with it also Laser Scanning Europe, who are our most important, we can say even key partners in this industry. And without the software of PointCap, which we in our hub software call the hub draw, our package would not be complete. So the PointCap part is always very important to have a full system of GeoSLAM. Laser Scanning Europe, working closely with PointCap, is our big partner and dealer in Germany. I'm happy to work with for all the time, and we appreciate them not only for knowing our products, but for having an overall expertise in the 3D laser scanning industry. So, as Martin was already introducing, the topic of this webinar should be flexibility and possibilities of mobile scanning using the GeoSLAM ZEB Horizon and its by-side products, ZEB Discovery and ZEB Locate, the backpack solutions of GeoSLAM, which we introduced recently. So it will be more a hardware session with a possible follow-up later where we can look, or some even of the PointCap colleagues can analyze the data. Today, I would like to focus mainly on the hardware side, but of course, we will talk something also about the software. So saying that, we are connected from all over the world. My colleagues are mainly working from UK, most of them also back from their homes as the situation enforces right now. Myself, I am based in Central Europe, in the nice Czech Republic, and you see a picture here, photo from the so-called Czech paradise or Bohemian paradise. So not exactly at that castle you see there, but not very far from there. And whenever the crisis comes over, you are very much invited to visit us in this region. And my position within GeoSLAM is to take care for the European distribution, which is mainly over our sales channels, our dealers, of which laser scanning is playing a big part for especially the German market. So what I would like to cover in today's webinar, you see our dogs are already attentive, so hopefully you are attentive and curious as well to see what I would like to present. I would start with something more general, talking about the challenges of modern industry, of modern surveying. Briefly, who is GeoSLAM? Because I think we might have some people who didn't hear so much about this company. What is GeoSLAM technology and the main applications? And then I will focus on the main part of the webinar, that is our products with main focus on ZEB Horizon. And I will talk about the versatility of deployment of ZEB Horizon in different environments, in different applications. And we'll talk about the two backpack solutions, and that's the ZEB Discovery we introduced last year at the Intergeo show in Germany, and then ZEB Locate, which probably most of you hear the first time about, and that's the combination of our Horizon with a GNSS receiver. Last but not least, I would like to show some marketing tools or present you some ways where you can study more about our products. Also watching maybe even more technical webinars which are done by our application engineers and by our partner companies as well. So starting by the challenges of new technologies, how we see them going in this so-called fourth industrial revolution, which involves basically digitalization of everything, of all our assets, and not only assets, of all processes we do. So all this requires a big change in our technologies, which we are using, because many new industrial segments ask for 3D documentation, not only at one time, but a continuous as-built 3D follow-up of every product. So much more than before, we've been asked for precise data capture, not only in the environment where we used to. Most of us were coming from the geodetical or surveying branches, but this precise data capture is coming from all different areas. With that, a big demand on mobility and speed of the data capture, versatility of deployment, and flexibility to use possibly one single measurement device for different applications. Of course, many branches which in the past were quite far away, like GIS and BIM, like geodesy, geomatics, environmental engineering, they are all coming now together with using similar formats of data, using cloud solutions. So we all are challenged by providing the optimum data flow, providing an optimum data maintenance with the proper formats. Looking particularly at the 3D industry, there is a big demand for the combination of visual and point cloud data coming from LIDAR. So I'm not saying that all this is covered by SLAM technology, but SLAM technology helps to accelerate and respond to all these processes of challenges of these new technologies. So just a few words for what this SLAM is about, and this should not be a scientific discussion about SLAM, but what this abbreviation stands for, it's simultaneous localization and mapping. So that's basically like solving something like as a chicken and egg problem, because while you change your position, your environment around you is also changing, and so you need to evaluate both these information. First, the environment around you with the changing position. So how we do it is by combination of the laser data measurements done by handheld LIDAR, and this device is carrying in itself also an inertial system and IMU, taking care of the positional data. These data together are processed in a SLAM algorithm. For this SLAM algorithm, it's of course a very sophisticated issue, which we are not talking in detail about, but it needs features, it needs objects. The more objects you have around, the better that technology works. It takes care of the scan-to-scan registration. As a result, you have first a local SLAM, and then at the end, you close a loop, you have a global scan, and what comes out is a registered 3D point cloud. So a similar data format, what would come out as of a stationary or terrestrial laser scanner. For you, probably known the formats LAS, LAZ, PLY, etc. What's great about the SLAM technology is no need to remain static while you do scanning. Actually, the more you move, the more dynamic you move the unit, usually the better you get the results. So that's a nice thing, and also no need for any additional positioning device like GPS. It works as a standalone system, and you can freely move all around. So what does GeoSLAM stand for? We call also the technology go anywhere. So it's independent on the fact if you're indoor, if you're outdoor, if you're underground or in the air. It's simple and affordable solution for rapidly mapping any environment around you. And the three main values, what we are always repeating when we talk about our main benefits, it's the speed of the surveying, which is in general about 10 times faster than using static surveying technologies. Of course, it always depends on the projects where you are. Sometimes it could be 20 times, sometimes it could be 5 times. But in general, in typical environments like buildings indoors, we are usually 10 times faster than the traditional terrestrial technologies. Simplicity, also we put a big value on the ease of use, that any operator, it doesn't have to be any expert, any surveyor at all, can use that technology outside. So he just needs to switch it on, a fixed position, initialize, and then go on in wherever environment he needs to survey in the range of 30 up to 100 meters, and then close the loop at the same point where he started. So there is no challenge practically for the surveyor who does the data collection. Of course, you need to know something about the 3D data when you then process the data, but it's the same as you would work with a terrestrial laser scanner. Quality is also a big value of us. We are pioneers in this technology, and the technology is behaving differently when you work underground, when you work outside in the forest, when you work in a building or from a car. So we analyze all of the projects of our clients, and we have a lot of case studies and reports analyzing the results of that particular surveys, and we put a big value on that because that's also the base of for us how to develop the products for the future. So GeoSLAM has about 20 years of innovation, even though the company is newer than that. Company was created in 2012 by a joint venture between 3D laser mapping. 3D laser mapping has been one of the innovator and first adopter of LIDAR technology in the world. So it was the first ever street mobile mapping system, which was introduced in 2005 by 3D laser mapping. And the company CSIRO, based in Australia, they're responsible, for example, also for the Wi-Fi technology, but they are responsible also for the SLAM technology, which has been adopted by 3D laser mapping as a first company who really saw a big commercial advantage to adopt it for this surveying industry. So you see a bit history of the products we have been having since 2013. First one, ZEB1, then ZEB Revo, and so on and so on. We don't have to talk about that in detail. I will come back to the products later on. So where can you find GeoSLAM? The headquarters is to be found near the city of Robin Hood, so near Nottingham, where Sherwood Forest is. So the contemporary Robin Hoods are now our chief engineers sitting in the office, but we are a worldwide company. So all over, we have about 100 employees working really in different corners of the world. So you see on this map that we have offices on both sides of United States, East and West. We have an office in South America. We are based in South Africa. We are based in Australia. We have an office in China taking care of South Asian business, and we have more offices in Europe. And also we are getting ready for the need to possibly also move our headquarters office because of impacts of Brexit. So we will see how that will be needed, but we are ready to take this step as well. So just a couple of examples of use. This is underground, in the air, or indoors. So looking at the main applications, as I said already, most of us are coming from the surveying industry. Most of our clients come naturally from this bench. So our survey and real estate management use our equipment for fast scanning to create inventory databases and floor plans. Next, very important part of our business, looking at our clients, for example, in South Africa, in Australia, in Russia, CIS countries, in Poland, it's the underground mapping and not only underground mapping, but also the inventories of stockpiles, which are naturally our clients, and they use not only the scanners, but for example, the volumes software we developed for that this part of these applications. Facilities and asset management business. So our customers in this spectrum are using our systems for condition reports, asset identifications, changing of, investigating the changes of warehouses, for example, like you see on that small movie with the warehouse model. So this is a very significant part of GeoSLAM clients. AEC, meaning architecture, engineering, construction, may be the most quickly growing part of our clientele because these guys are more and more using the BIM technologies. They are more and more forced to go to BIM and to survey the construction in as-built status. So in the situation, in the current situation where it is, and practically survey the history of every building. So this BIM business is very popular in EU. It's coming from the Western Europe, also to Eastern part of Europe, and it's expanding its popularity also in United States. Conservation or everything what's environmental business, we have many clients using the equipment for forestry management and inventory, as well as for capturing historical buildings, for preservation and condition management. In this periods where we are ourselves now, the questions of security and defense are important. So we have clients working for, you know, this defense industry. For example, building floor plans for hospitals, for schools. All this is very needed for the current safety, also in this situation of COVID-19. And education, last but not least, these are also our partners. That's why we created very interesting discounts for all educational institutions, be it research institutes, universities, because they can buy our technology for a really good price. But we also use their expertise to develop our products. And many of the students are doing their thesis using our products, and I think it's both sides benefit of this. So as you see here, the technology can be used almost everywhere. This is a combination of our own colleagues working in different environments and our dealers and clients. Looking at our family of products, it's mainly 3 products we are offering right now. It's the ZEB Revo, or we call it also ZEB Revo Standard. That's a scanner with 30 meters reach for especially indoor applications. And that's the most rugged one. We recommend, for example, for underground mining. And that's the most cost effective also of all. So in other words, even though I hate the word cheapest, but it's the most price attractive out of the ZEB family. ZEB Revo RT is a development out of ZEB Revo, development in direction real time. So what you do in the field when you survey, you do not only do your scanning, but at the same time, you process the data in real time, and you can see the scan, the results of the data already on your screen. So you can see if you already surveyed the particular room, for example, and it improves the speed of processing. So normally, if you use the post-processing equipment, you would need approximately the same time for surveying, for the data collection, and the same time for processing. Using that real-time product, you save this time of processing, so you are much more flexible. So ZEB Revo RT is our main product for facility management indoors for real estate industry. That's where this unit is used at most. Then over to ZEB Horizon, and ZEB Horizon should be the main subject of today's webinar. That's the most versatile system, most flexible, because you can really use it for many different applications, many different deployments. So you see here on the picture a couple of them, using it in a combination with the NCT camera 360, using it on the drone, or using it in a combination with a GPS receiver. So this is something, the versatility of ZEB Horizon is something I would like to focus on in my next slides. So how we evaluated that ZEB Horizon, we introduced it the first time also at Intergeo. Of course, every product must be introduced at Intergeo, as you know. So I don't know what we will do when there will be no Intergeo this year. But now, okay, 2018, ZEB Horizon was launched. Since that time, it had a lot of development in terms of not only software, but the accessories we added to that. So one of the first was the UAV mount we added to put it on the drones. Another one was to create a cradle for the miners or for all those who use it for vertical applications. Then we created a solution to come, for example, into voids, ceilings, on a long pole. Then we created a solution enabling to do a simple 360 documentary picture, which is then allocated to the scan data. So that's what we developed from the beginning. The last development in this respect was the ZEB Discovery, what I will come later on. So that's a combination of the ZEB Horizon with the precise NC Tech panoramatic camera. Last but not least, something I will talk about at the end of this presentation is development in terms of adding a GNSS equipment and also a car mount. What comes next, that's what we see. We see a lot of potential sensors we can add to ZEB Horizon. Many of them we tested, our development is working on many different sensors like QR codes, temperature sensors, Wi-Fi, Bluetooth sensors. So everything that can be added to the information coming from the laser scanner. So it's really a very exciting development we can move for our next generation of products. So this is taken from our product catalog. You see that in the center you have ZEB Horizon, and you have many different possibilities to mount it on different platforms. So in terms of accessories, I already mentioned a cradle for lowering up it into deep shafts. Many clients for that doesn't have to be shafts. It can be, for example, an oil tank where we have some of our clients using this cradle, a pole for raising it into ceiling voids, and already mentioned the ZEB panel, which is an interesting development we did mainly for our clients in real estates. A couple words more about the UAV. So as I mentioned already, the ZEB Horizon is ready for UAV. That's how it was designed from the very beginning. And the idea is when you take the Horizon in the air, you don't have to you don't have to carry any other positioning devices like any expensive inertial measurement units. You just carry one single device, and it does all mapping of the area under you. So we developed a special mount for the DJI Matrix 600 drone. This mount can be adapted also for different type of drones. The only thing that you need to have in mind that the weight of the Horizon, including the data logger and battery and the mount, is something like 3.8 kilos, so almost 4 kilos. So you need to have a stable drone which is capable of carrying such a payload for a period of some 15 to 20 minutes, which is reasonable enough to collect a good amount of the data. So many of the clients use it for power lines, railways, housing estates, industrial buildings. Also, very popular it is for forestry and rural business on farms. We have our own experts in pilots working with this solution practically daily, so they are capable of providing you a very professional demo, and we have our full equipment for doing that, and so we can either invite you to our headquarters in UK, which at this time it's a bit complicated, but I'm sure that later this year it will be possible, or also visit you with our application engineers to make sure that your UAV surveys is done properly and that you can fix the horizon to your drone. So just something to think about when you do UAV survey. Again, from the principle of the SLAM technology, you would need an area with features. So it would not bring you very good results when you have just a pure surface with a field, a planar surface with no features. Then this technology would not bring you the results you are hoping for. It needs to be a good topography, some hills, but it doesn't have to be hills. It can be buildings. It can be poles. It can be trees, etc. But there needs to be some topography in the terrain. So we have found we can suggest you how to define your flight plans according to the area and features you are doing. We have our experts doing that, and of course, when you survey, you need also to georeference your data. So we can provide you advice which checkerboards you need, spheres, and how best you can georeference your data. You can also add a camera to the ZEB Horizon, and that camera helps you to colorize the point cloud. So this is for some applications also quite interesting. But maybe I forgot to say that even without camera, the ZEB Horizon is capable of extracting the so-called intensity value. So this intensity helps you already to distinguish between some materials. So it helps to identify the many features and many subjects on the ground. Very recently, this is a development for the last couple of weeks. We introduced also a car mount and did some tests with it. So we used again the same click and go technology using a B mount so that you can simply click on your horizon on that. And we created, our development engineers created a magnet mount with screws where you can simply click on the horizon. So this is some engineering pictures, how you do that. Of course, we will provide you all support when you want to mount the horizon on top of your car. Just a reminder, it needs to be a metal car's roof out of the simple fact that it's a magnetic mount, and we take care also about safety. So we are delivering it with the safety car straps in order to really be sure that the equipment is fixed on the roof of the car, which is of course very important. There is two ways to mount the horizon on the car. You can mount both the horizon with data logger on the roof, but you can also mount only the horizon and then connect it by a 5-meter system cable. Suitability is more in town centers, small roads, and any small projects. You should not go on motorways or big roads the general principle is that the speed limit should not exceed some 30 miles per hour. So talking more in a European way, it's something like 50 kilometers per hour. That should be approximately the maximum speed. But this is quite reasonable. I think with 50 km/h, you can already move really efficiently in many directions. So if you do a survey using a car, you should ideally also follow all the rules as if you would do a handheld survey. So not going over maximum capture time of some 20 minutes, and ideally come up to the same point at the end of the loop, within about 1 meter from the start location, the same point facing the same features around you. Also try to avoid when there are too many cars moving around you. So it's better to plan a survey in the time where there is not so much traffic. If there is a couple of cars going around, it should not be so significant. But if you have an option to avoid it, that's always better. So consider also driving not only in the loop, ending the loop on one place, but even within the project, it's better to have more loops, and then also come back to the position where you started, ideally from another direction than when you started your projects. We also recommend some processing parameters when you do your car survey, for example, to increase the convergence threshold or window size to 2 or 3. So as you know, our hub software has some default parameters which run usually your scan. But depending on the application, we recommend to change some parameters. So those are ones we would recommend to change for your car survey. Also, you have now the option to tick the start and finish closed loop. As I said, we always recommend to end up at the same point, but it's not always possible. So if you unclick that option, you can also do your survey with some risks, but if you unclick that option, there is a good chance that you achieve reasonable results, even though you don't close the loop exactly on the same location. So here, a couple of tests. So you see that with different speed of the car, you achieve a little bit different data. So with increasing speed, the data become a bit more striking. So this is a comparison coming from 5 miles per hour over 10 and 20 up to 30 miles per hour. So you can see the differences. But you see also that with the maximum speed, it still can be used for many purposes for which you use normally the mobile mapping systems in a car. So driving speed can affect the point density and also the intensity. So, for example, the detection of the road marks. Here you see one example of data captured in Raddington. That means in the industrial area where GeoSLAM is located near Nottingham. So you see a capture of about 8 minutes with some 50 million points with a variable speed between 10 and 30 miles per hour and capturing about 2.5 kilometers of the road. So you see that within 8 minutes, it's a nice area to cover. And this is a similar example, but using the ZEB cam. When we use the ZEB cam, then naturally we had to decrease the speed because using the ZEB cam data involves to calculate with some reduced speed to correctly evaluate the colors. So in this case, the car was moving with an average speed of 5 miles per hour and was capturing this particular area for 10 minutes. Again, some 51 million points, and the results look very nicely. Of course, all the results I'm showing here, you see just pictures, photos. We can provide you also in raw formats for you to make yourself an analysis how the data look in detail. It's another example of a stockpile surveyed in 4 minutes with a car amounts about 80 million points. So that's enough. I talked to you about the car applications, and I would like to come back to the product I was already mentioning, and that's the one we really think that it can bring us in new industries, especially in street planning, urban mapping, something like modern planning of cities, and that's the discovery. ZEB Discovery synchronizes the data on the horizon together with a precise 360 camera, and we use our partner company NC Tech. So it's a high resolution camera for rapid urban mapping. And we think that's a significant step towards new technology, new applications from utilities, heritage, and other growth sectors, and also in a way competitor to some products we have not been in touch with, like all the backpack systems using a combination of different positioning methods. So if you look at the specifications of the ZEB Discovery, it's the core of the product is the ZEB Horizon, creating 300,000 points per second, and the NC Tech camera, 360 camera, one of the best cameras in the market with 11K spherical resolutions, delivering 60 megapixel panoramic images 7 times per second. And for these two main sensors, we created a very rugged and also ergonomic backpack which carries these both sensors and all accessories in an easy way. So you have data logger connected to the backpack, and also battery. And we make sure that one battery in this case is feeding not only the horizon, but is feeding also the NC Tech camera. So we minimize the cables. So the solution is really very compact. On the top of the camera is also a GPS. In that case, we speak about like a low level or middle class level GPS, but it allows you to position your point cloud within about 1 to 2 meters on the map. So this is for localization of your project on the Google Street Map, for example. So if you look at the ZEB Discovery, it's a combination of high resolution imagery with SLAM point cloud, no need of GPS. It just the GPS helps you to know where you are. And we use our partner company, it's Orbit GP, which we analyzed is the best one to visualize the data and also to extract the necessary features from the data, and also to ideally combine the imagery data coming from the camera with the LiDAR data from the scanner. So Orbit GT is our default solution we offer with ZEB Discovery. You can buy from GeoSLAM the whole package, including Orbit, but we also make sure that you can get Orbit from another source, and we are developing other options. So we don't want to be dependent only on the Orbit software, but give the clients the option to select the software they need to properly visualize, analyze the data, make navigation in the data files. As I already mentioned, we use that flexible clip and go technology, and that's something very, very nice because you only click within a second the horizon to the construction, and also the data logger is clicked on. So very, very easy. When you unclick, you can carry it for the next project just in hand. And then with the next click, you click it, for example, on the car mount, which I showed previously. So this clip and go technology will be the core of our development for future sensors as well. What comes in a box, you will receive quite a big case, hard case, but this hard case is designed that it incorporates everything what you need to easily set up the complete discovery systems. So it's quite nicely inside. The weight is about 10 kilos of the overall system. And it's an ergonomically built. So if you carry it on the back, it's really nothing so difficult. Okay, I don't want to go too much in detail in these technical drawings. It just shows you how you assemble the discovery. But as I mentioned, we use a simple click-on system, and this assemblage is done within a couple of minutes. You have a full system ready to do your survey. As I mentioned, we offer an Orbit GT software with that. And with Orbit, we also negotiated a special package, what we offer. So this is a description of what that Orbit package includes, all the feature extractions, which is very interesting to automatically detect or semi-automatically detect features like trees, lampposts, curbs, etc., and to easily overlay the data coming from the images and from the laser sensors together. So that package is a special one created for GeoSLAM, and we think that we have in this package everything what's necessary, including the referencing, for example. But if you have your own source of Orbit, you are not obliged to purchase Orbit from GeoSLAM. You can use your own suppliers for Orbit. So with ZEB Discovery, we say urban mapping for the smart cities of the future. Here, a couple of examples. This is some scanner and images data overlaid from the center of London survey, which was over some 15 minutes. The GPS of that NC Tech camera provided you with the trajectory you see on the top in these blue colors, and you will always see the spots where the images were done. And you see also here the trajectory, or here the blue spots every time when an image from the camera was taken. So of course we have a lot of examples we can share with you in different formats, so you can see the projects we have been done so far. So this again, center of London, an area which would be very difficult to survey using mobile mapping from the car, but using this backpack solution, very easy to walk through and do it within 15 minutes in this case. We have also users who are working with a bike, so they simply take the backpack on the bike and do their route by cycling. Okay, that's our colleague Sven, who is unfortunately not anymore with us, but he's still important with us for us because he works for NC Tech for the manufacturer of the camera. So we are still in close contact with him. So I think I'm talking already a bit too long, so I will quickly jump over some slides which explain you in detail the data flow from the ZEB Horizon data and the camera data into the Orbit software. This presentation I can provide to all of you is done by our application engineers and explains really step by step the work flow of the data. So you first do the processing of your Horizon data, and then you copy the data from the camera on your computer, and okay, export the data and trajectory in the correct destination, and then you use a tool, a new tool of GeoSLAM that's not a part of the hub software, but it's called ZEB Discovery Image Processor. And in this image processor, you stitch the data from the horizon together with the data from the camera together. You add the trajectory, and as a result, you have a synchronized data file, which takes care of the basically of the proper synchronization of the data so that they get properly aligned. This file of the aligned data is then the basics to import. Okay, you see, you can also select your coordinate system, etc. But this result you import into your Orbit software as an SCV file, and here you see the your results in that Orbit software. Also for the Orbit software, we have step-by-step explanations, how to use the extraction module, etc. So all these we can provide you a good training how to work with Orbit software, not only in these in a way of PowerPoint presentations, but my colleagues Joanna and Ivona, they also did webinars on this topic, so it's described very much in detail. So as a result, what's Discovery's main strength is a flexibility and ease of use for a very affordable price when you compare it to other backpack solutions providing you the same. So we rely on the SLAM technology, which allows us to have a system which is not too heavy, which doesn't have any expensive IMU sensors, but which is a very, very simple to use in different environments. So we also, what is important for us, because we have, maybe some of you are our clients already, having the Horizons, we want to allow the optimum possible, the best possible update to Discovery. So if you have the Horizon system, you can then buy Discovery updates, in a modular way. So for example, you can buy an NCTech camera from us, but you might have an NCTech camera from another source. So in this case, you would buy only the software part, and you would buy the backpack frame, which is necessary to carry it. By the way, the backpack frame can be also very practical to you, independent of if you are a user of Discovery or not, because it's a good way to carry the Horizon itself and not having it in your hands. So this way of update of your current system is made very easily for our current products. And I hope I'm coming slowly to my last slides, and I hope you are still patient, like this small dog of our sales manager, Darren, is still watching. So that's the last product that I want to introduce to you is a ZEB Locate, working again on the same principle, using the same backpack frame as the Discovery system, but instead of the NCTech camera, it's using the GPS antenna on the top. So it's what our clients is all those who need a simple way to get a geo-referenced point cloud of a good quality. The idea is that we provide you with the hardware and software tools to add any antenna of your choice, any survey grade antenna, ideally. So any antenna providing you an NMEA output of the data. We have done our first test with Trimble Catalyst antenna, but we know that we can work with practically any antenna of survey grade providing the NMEA output of the data. We are now talking about post-processed data. This technology is not working in real time, but if you work with the GNSS antenna connected to the Horizon, you can then later in the software georeference very easily the data together with the point cloud. So how it works, you capture the data as you would do normally. You need to do it at the same time, of course. So you synchronize the switching on the GNSS antenna together with the laser scanner. You copy the data to the computer. You first process your SLAM data in the hub software, and then using our separate application again, you process the SLAM data together with the GPS data. And this ZEB Locate software takes care of that these data are synchronized together. And as a result, you receive a georeferenced point cloud. So that's it. The use here is very simple. We are now trying to test more and more GNSS antennas. We as GeoSLAM will not provide the GNSS antenna because we are not manufacturers here, but we can recommend you to test your own GPS antennas, provide us with your feedback, and if there is anything we need to add. We know that we need to add, for example, projections, because right now it works only in UTM coordinate systems, but this is something we are working on. And one very interesting feature we are working on is also adjust to control. So it means adjusting the point cloud itself, so that based on the fixed points known by the GPS, we can also adjust the whole cloud of the survey, which would be a very interesting feature again to increase the accuracy and the reliability of the data. So I think, well, this is some our results. How accurate is ZEB Locate? So all our test results show typical accuracies of some 20 to 30 millimeters against the control network. So these are the data which we did with the Trimble Catalyst GNSS receiver, but we are now testing some other manufacturers, some other antennas as well. So this is what you can expect, and we are convinced that with the upcoming adjust to control functionality, we will be able even to lower down this accuracy. Interesting also is that you don't have to take care. You can combine your indoors and outdoors survey. So you start outdoors, use your GPS, but in the meantime, you go into a building and go out, and the software is capable to filter out this time where your GPS coverage was not sufficient based on RMS values, based on PDOP values, or some other criteria. Again, similar principle to ZEB Discovery, also with ZEB Locate, we want to make it affordable to our users of ZEB Horizons, to our existing clients. So they all only need to purchase the backpack frames, the V-mounts to mount that, and some enhancement of the software. So I think I talked already probably over the time I was supposed to. So I hope that I'm sure that we have many English native speakers, which would be much more better to do such a presentation. I hope that it was at least interesting for some of you. I'd like to show you just briefly where you can get more information on our products. Check our GeoSLAM webpage, and we work on that now very intensively because the marketing department now focuses on all activities we can do now indoors in the current situation. And we have also, we call it Academy, geoslam.com/academy, and that's a platform where we store some of our webinars, some of our technical information, not only about our own software, but also about third-party software like Orbit. So also a very interesting tool to learn more. When you use that Academy, it would ask you to enter your own credentials and also the serial number of any ZEB receiver you are using. But don't worry, if you are not a ZEB user yet, you can use a simple number 99999, and it will allow you to use that Academy. I think it's a really useful tool. Some of you watching this webinar are already dealers of us. That dealer webpage, dealers.geoslam.com, is a platform where we store all our webinars. We are now practically having every week 1 or 2 webinars done by my colleagues, which are in many cases much more qualified than me and are experts in different parts of our hardware and software. So it's very exciting. You should not forget the webpage and other media of our partner, PointCap Software, because I have to admit that many of our clients, they learn about the hub draw also from the PointCap platform, where they have really very, very good tutorials and videos, etc. And many of this is found on YouTube. So if you click on GeoSLAM Hub, GeoSLAM anything on YouTube, you might be surprised how many tutorials and interesting tools you will find there, because it has been done by some of our dealers, some of our partners, etc. So last but not least, if you have any questions, I'm happy to answer. You will see here my email address and phone number, and I will be happy to respond to your questions. And if there are any questions now from that webinar, maybe I ask Martin to pass them over to me, and I will try to answer them right now. And thank you very much.
Thomas, there are. So thanks for the talk, Thomas. And I think it was very interesting to see the overview over the different product family of the ZEB family. The first question I'd like to answer myself. So the question was, does the kit come with a dog? It was regarding the question was coming in when you were on the third slide or something, where you showed the ZEB Horizon with the dog. And yes, you can have the ZEB Horizon coming with a dog, not that dog, but another dog. The mount is available as well, so you can send out your dog. He can walk up the stairs himself, and everything is fine. And of course, this was a joke. But going on with the next questions. Does the operator can see the result same time in the scanning process? Thomas.
The operators see the scanning process in case uses the RT product. So when it's the ZEB Revo RT, that is connected by Wi-Fi to any computer. It can be a tablet, it can be a laptop, but it can be also a smartphone. And in that case, you see online your point cloud in real time, what you survey. In case of using this Horizon or the ZEB Revo standard, it's a post-processing technology. So first, you don't see anything. You scan your data, then you need to process it, which the time of processing is the same or a bit longer than the time of scanning, and then you will be able to see the data.
Thank you. Next question is, could neuromorphic computing, something like machine learning, for example, or AI, be added or integrated to the ZEB Horizon so it allows to recognize shapes and patterns?
Very good question. It's something our development team is working quite intensively. So this machine learning, we have experts, and there is already versions of the software as beta versions, so we are testing them, capable of identifying some objects by that learning. So that's certainly a future of this technology.
Okay, and the last question, which I can see here currently, besides the thanks from the crowd to you, Thomas, is if they can have a PDF version of the slideshow.
Yes, for sure. Yeah.
We can include a link to
either to Martin, to PointCap, or if you provide your email address.
Thomas, we will include a link to the slideshow, to the PDF version in the follow-up email, which you will get in around 24 hours.
Okay, good.
Perfect. Are there any more questions? It seems like this is not the case. So thanks again for your presentation, Thomas. If you are interested to hear more about the GeoSLAM software side, I am going to have a webinar next week, Thursday, together with Ivona Hubova from GeoSLAM, which will be called It's Not Yet Online, Best Practices and New Features. We will show new things in both softwares, which will come out 2020. And we will show the workflow, how you can combine terrestrial laser scan data together with GeoSLAM laser scan data. So if you're interested, this webinar will be online soon, so you can join that next Thursday. And of course, check out our other webinars as well. Yep. So since there are no more questions,
thanks for inviting me. And
Thanks, Thomas, for having the webinar, and everybody else, have a good night, morning, day, wherever you are located. Bye.
Okay, see you. Bye.